All right, buckaroos and buckarettes, we're going to talk about the mole now. This is where we are in the textbook. This is chapter 3, section 3, and it's actually about it starts on page 80, um, 82. We'll say 82, page 82. But there's hardly anything more important than learning about this mole and how to use it. And so we'll just go through some basic definitions. A mole is actually a number. The number is 6.022 times 10 to the 23. Okay, this should be a superscript here. And it's also known as Avogadro's number. All right, Avogadro didn't actually arrive at it, but his work brought them to it. And how we use it in chemistry is we take this mole and we take this number of atoms and we relate it to the mass on the periodic table. And so if we're talking about that number of atoms of any element on the table, we call that the molar mass, and we express that in grams. Okay? So sometimes you'll hear it mentioned as the gram atomic mass. I think you'll catch me saying that frequently. I think our book tries to stick with molar mass, but it's the same thing. The gram atomic mass is the mass in grams of 1 mole of any element. So for carbon, it'd be 12.01 grams per mole. For oxygen, it would be 16.00 grams per mole. For nitrogen, it would be 14.01 grams per mole. Okay? And that would be per mole of nitrogen, per mole of oxygen, per mole of carbon. And so these things you see you can use as conversion factors. That means you have over 100 conversion factors on the periodic table. So this is what we're talking about here. 1 mole equals the molar mass. And so we can use these conversion factors either way. 12.01 grams of carbon per 1 mole of carbon, 1 mole of carbon per 12.01 grams of carbon. Now, how would we use that? Well, let's suppose that we were trying to convert, say, 0.25 moles of carbon to grams. Okay, so the moles of carbon would cancel here, and we'd multiply this by 0.25. Here, we would say we're trying to convert grams to moles. Okay, so on this side, moles of carbon would come out. Another example here is with chlorine. Okay, so if we were trying to convert grams of chlorine to moles of chlorine, we would use this expression. If we were trying to convert moles of chlorine to grams of chlorine, we'd use this expression. And on and on and on with every element on the periodic table. Okay, now, so this number, and then again, this should be a superscript. This number then is the number of particles. And when we say particles, it could be atoms, it could be molecules, it could be ions, it could be isotopes. If the truth be known, it could be golf balls or chicken eggs or whatever else, right? So when we're talking about converting moles to particles, then we're going to use this number. And only then do we use this number. Okay, when we're up here converting moles to grams or grams to moles, we don't need this number per se. Okay, we're using the abbreviation mole. Okay, because the mole is going to relate to the gram atomic mass or the molar mass. But now here, when we want to know actually how many particles we're using, we have to incorporate this number again. That should be a superscript. Okay. So here, if we were going to convert a mole of iron atoms, okay, to individual atoms, we would multiply it by this. We would say that 1 mole or a half a mole or a tenth of a mole or whatever of iron or any other, and I say any other element multiplied by number of particles per mole. Okay, so this would be a conversion factor. And then if we wanted to convert the number of particles to moles, we would use this conversion factor. Now, another conversion factor we use with moles, and this is introduced here in this section, is this idea of ideal gas. Ideal gas at STP. Ideal gases are most gases that we relate to, and STP is standard temperature and pressure. Okay, temperature and pressure, and it's very easy to use because standard temperature is 0 degrees Celsius, standard pressure is 1 atmosphere, and that's about what's going on in this room right now. Okay, so at STP, any ideal gas will occupy 22.4 liters. So whenever you're asked a question about a gas, you'll see this STP mentioned here, and you can convert the volume of the gas to moles, knowing that any ideal gas at STP occupies 22.4 liters. Also, if you were given, say, grams of helium here, you convert the grams to moles, and then you can multiply the moles times 22.4 liters per mole, and that would give you the volume of the gas. Okay, so that would give you the volume. This would give you the moles. Okay, and that's just a couple different ways that we use these. Now, when we look at, after you read pages 82 and 83, we go into some practice problems here on gram to mole conversions, and uh, this is where you want to make sure that you have all these under control. But let's take a look here at first to make sure you understand that what we're talking about is this mass right here. This mass on the periodic table will be used as a conversion factor. 1 mole of carbon over 12.011 grams, okay? Or 30.973 grams of phosphorus over 1 mole. These are your conversion factors right off the table. Iron, 1 mole of iron has a molar mass of 55.845 grams, okay? So you got to understand that these conversion factors, if you look at this particular periodic table, what have we got? 118. So you have 118 conversion factors, times 2 actually. Some of these don't have real masses here, but in theory, you would have that many conversion factors from the periodic table. So that's straightforward. It's not difficult to understand where the conversion factors come from. Most of the conversion factors you use will come directly from the periodic table. Okay? Now, this is a little diagram. I like it. It's not going to, let's see if it's going to let me see the whole thing. And what it's trying to tell you is that whenever you're going from representative particles, again, representative particles most often are atoms, but they could be molecules. You could be talking about water molecules, could be ions, could be isotopes, any particles. Again, I said it could be chicken eggs, okay? But whenever you're going from any number of particles and you want to go to the mass of those particles, or if it's a gas, you want to go to the volume of those particles, you have to go through moles, okay? And that's what this diagram is trying to tell you. If you're going to go from particles to mass, you have to convert to moles first, okay? If you're going to go from particles to volume of a gas, you got to go through moles. Same deal. If you're going from the volume of a gas to how many gas particles you have, you got to go through moles, okay? If you're going to go from the mass of a substance, which we normally do, the mass of let's say you take the mass of a gas and you want to know what volume it would occupy at STP, you got to go through moles, okay? So this reminds you, when in doubt, this is my, I sort of joke about this, but it's not really a joke. When in doubt, convert to moles. And that is one of my mottos, okay? And I think you need to stick with it. Take a look at it, okay? Now, let's take a look at a couple of these questions here on page 80. Let's see, the first ones are on 85. And it says, what is the mass in grams of 2.25 moles of iron, okay? So you take your line here, and you need to be even more particular about it here in the beginning while you're learning how to do this, okay? You take your line here, and you take what you're given. Well, you're given 2.25 moles of iron, okay? And what's it asking you for? It's asking you for grams of iron, okay? So simple, okay? You're using an element. What you're going to do is you're going to go Back to the table. The mass, the molar mass of iron is 55.845 grams. Remember, if you took this mass in AMUs, that would be the mass of one iron atom. If you take that mass in grams, that's the mass of 1 mole. Okay, that's the mass of 1 mole. So you want to convert to grams, so you're going to take the 55.85 grams of iron per mole, okay, and you multiply across the top. Okay, you multiply across the top, and you'll end up over here with 2.25 multiplied by 55.85 grams. Okay, the moles have canceled. This is grams of iron, and it's going to be divided by 1. The mole's gone. Okay, so that is your answer. Remember, these vertical lines represent either multiplication or equals, right? Okay. These are just to demark your steps. All right. So what you need to do is get to work on these problems. Okay, page 85, and let's take a look and see if we can't work some of these problems out. Bring them to class. Try to lay them out as far as you can like this. Then bring them to class and ask, and I'll be glad to help you with them. Okay, and that's what we need to do. Alrighty. Thanks.